Fifth grade into math, lesson 5.4. Find volume of right rectangular prism. I can find the volume of a right rectangular prism using the area of the base and the height. Spark your learning. For his junior engineering club, Miguel is designing a box in the shape of a right rectangular prism that can hold exactly 12 1-inch number cubes with no extra space. What are the dimensions and the volume of a box Miguel can design? Okay, so what we need to do is we need to come up with our different ways that can happen. So this one is a what? This box is 4 by 3 by 1, right? Okay, so we need to get stuff that's going to equal 12, right? Okay, so how can we break this apart? Could we do 2 times 2 times 3? Okay. What's another way? Okay, so 12 times 1 times 1. What's another way? Okay, so 6 times 2 times 1. How else can we break the 6 apart? 3 times 2 times 1. Oh, times 2, sorry. I put the wrong thing. Okay, anything else? Oh, yep, so you're right. We did already use that. So we talked about before where you can use it, you just don't want you can have different orders, you just don't want the same numbers repeated, right? Okay. All right. Build understanding. Naomi works at a health food company. She needs to stack 1-inch protein cubes into a box as shown with no extra space. What is the area of the base of this box? Okay, so you just want to know the bottom, the red, right? Okay, so what, how many across do we have? What's our length? 4. And what is our width? 2. So 8, what?
8 square inches.
8 square inches, because it's set up here, right, with inches. 8 square inches, or you could write it as 8 inches squared, right? To get either way. What is the volume for one layer of cubes? Okay, so only one layer. So how thick is a layer? Only one, right? So it would still be 8 what? 8 cubic inches, because we found the volume, right? All right, because volume equals length times width times height. And in this case, volume equals the length was 4, the width was 2, and the height is 1 because we only have one layer, right? Okay. How is the volume of the prism different from the area of the base it is sitting on? So we got 8 for both. What's the only difference?
One is cubic because it has.
One is cubic inches and the other is square inches. Okay, so volume uses cubic inches and area uses square inches. In this case, anyways, right? Okay, and what I mean by in this case is we use inches this time, right? But otherwise, volume is always measured in cubic units, and area is always measured in square units, right? As each layer is added on top of the base layer, how does the volume change? So when each layer is added, is the volume going to increase or decrease? Okay. So the volume will increase. Complete the table to find the volume of Naomi's box. How is the volume related to the height? Okay, so basically for each layer, she's going to keep adding how much? 8, right? So the first layer was 8. The second layer is going to be 16. The next layer, 24. The next layer, and the fifth layer. So what is the volume of Naomi's box? So it's the total volume. 40 cubic inches, or you could also write it as 40 inches cubed, right? And then we forgot to write up here on this line that the height increases 8 times. As you move up. Angela is a culinary artist. She wants to pack the 1 centimeter food cubes into a container as shown. What is the volume of 1 food cube? How do you know? Okay, so what did it say up here in our whole reading to begin with? It said that each one was 1 centimeter, right? And a cube, all sides of a cube have what? The same dimensions, right? Okay, so 1 times 1 times 1 is 1. So the volume of 1 food cube is 1 cubic centimeter because a cube has all congruent sides. So 1 times 1 times 1 equals 1, right? How many centimeter food cubes will she pack into the container? How can you use this amount to find the volume of the container? So basically, everything's 1 centimeter by 1 centimeter, right? So whatever we get for the volume of the container, it looks like they're all tightly packed, right? So whatever the volume is, that means that how many cubes there are, right? Okay. All right, so how many do we have for the length? 6. Okay. How many do we have for the width?
7.
Okay. And how many do we have for the height?
7.
Okay. So what would be 2 numbers that we could easily put together? 6 times 5, which is 30, and then take 30 times 7, which is 210. So you can pack 210 cubes into the container. Okay, and then how can you use this amount to find the volume of the container? So we did volume equals length times width times height, right? And in this case, the volume was, the length was what? 6, the width was 5, and the height was
7.
Okay, so what is the area of the base of the container that Angela needs? So area equals what? What's our formula for area? Length times width, right? So in this case, area equals what? What's our length? 6. Our width is 5. So what is 6 times 5? 30. So 30 square centimeters, right? So letter D, what is the height of the container? So what is the height of the container? 7 centimeters. Then they want us to write a numerical expression using the height to model the volume of the container. Volume can also be volume equals area times height, okay? So if we were to use that equation, what would we plug in for the area? Would we say 30, right? So 30 times, what's the height? 7. Okay. What is the volume of Angela's container? How does your answer compare to that of part B? So we kind of already found that, right? Okay. So we said that the volume was what? 210 cubic centimeters, right? And then Answers B and F are the same. Angela rearranges her 1 centimeter food cube as shown. What are the length and width of the base? So what's our length? How many cubes do we have? 7. What's our width? 5, right? Okay. So the length and the width are, so length is 7 centimeters, right? And the width is 5 centimeters. Write a numerical expression for the area of the base. So what's our formula for area? Area equals length times width. So in this case, it would be 7 times 5. And then our area would be 35, what? Or square centimeters. Or you could write 35 centimeters squared, right? What is the height? So this is 6, right? So 6 centimeters. Write a numerical expression for the volume. So we said you can also write volume equals area times height, right? So we would write what? 35 times 6 for our expression. Use your expression to find the volume. How does your answer compare to the volume you found for step it out 2? So over here I could write 35 times 6, right? So that's 30, put the 0, carry the 3. 6 times 3 is 18, plus 3 is 21. So it would be 210 cubic centimeters. And then both answers are what? Are, let's say equivalent this time. And then when we use the word equivalent, that means they are the same, right? Okay, so check for understanding. 1 layer of 1 centimeter bouillon cubes is shown. If 8 layers are stacked, what is the volume of the right rectangular prism formed by the stack? So in our picture, do they give us the height? No, we have the height right here, right? Okay, so what is our length? 4. What's our width? 1, 2, 3, 4, 5, right? Okay, so our formula is volume equals length times width times height. What is our length? 4. Our width is 5. And our height is 8. So 4 times 5 is 20. 20 times 8 is 160. So our answer is 160 centimeters cubed, or I could write cubic centimeters, correct? Okay, so find the volume. So for number 2, what's our formula? Volume equals length times width times height. Okay, you need that on all your problems because that's part of the work. So volume equals, what's our length? 3, width 2, height 4. So it would be 6 times 4, right? Which is 24. And then cubic inches, or you can write it as 24 inches cubed. So either way, right? All right, number 3. So once again, we start with our formula. What's our formula? The volume equals length times width times height. Volume equals, our length is 6, our width is, and our height is. So 6 times 3 is 18 and centimeters, right? So cubic centimeters or 18 centimeters cubed. I would take it either way, right?